Hey, everybody. Welcome back to the Lion's Den. Today's a fun one. We speak with Professor Neil Comins, who is a professor of physics and astronomy at the University of Maine. It's not often that we have astrophysicists on this podcast. So I really took this opportunity to ask him some of the more complicated questions that I ponder late at night. Things about, time. What is time? What do you think about space travel? Is it ever going to be possible? We talked about some of the crazy experiments in quantum physics and what they mean for our world and consciousness and everything around us. It was a really, really fun conversation. I kind of want to do more of these. So anyway, check this out. Neil, welcome to the Lion's Den.
Thank you. Great to be here.
Awesome. Should I call you Professor Comins?
No, Neil is fine.
Okay, sounds good. So I'm super excited to have you on. The world of physics and astronomy are super fascinating to me. In my opinion, all the best movies are centered around those topics in those areas. And I really like to think about these topics because it's sort of like when I'm just like sitting on my own, pondering like our existence on Earth and what are we doing here. This is where my mind always drifts. So I've got three big topics I want to hit on with you today. We can throw some ideas around. I want to pick your brain. The first one is time. All right. Pretty broad topic. So let me just give you a super high level. We can kind of go wherever you want from here. But so some interpretations of time, or interpretations of physics, I guess we should say, suggest that time is like an illusion and that everything past, present, future all coexists simultaneously, and that our awareness of time is tied to our consciousness and our memory. Do you think that time exists independently of us and of consciousness, or do you think it's linked to our perception of our environment? Like, what is your perception on like what is time? How does it work? How do we perceive it?
First of all, I definitely think that time is independent of our perception of it.
Okay.
It is something that is flowing. It is something that has changed since, quote unquote, the beginning of time, and continues to change and will change even if we were not here. So it's a fundamental underpinning of the properties of nature. However, having said that, I might also add that time is not a single is not the same for everyone. How about that? Time is not the same for everyone. Rather, it depends on where you are and what you are doing. And by that I mean, wherever there is matter, like the earth, like the sun, whatever, wherever there is matter, time passes more slowly than when there is no matter or less matter. So the concept of the passage of time here on Earth and the passage of time on the moon, they're not the same. And when we colonize the moon, we're going to have to synchronize clocks, knowing the different rate that time passes in those two different places and anywhere else. So that's the issue of the location and its relation to time. The other relationship is motion.
Okay.
The faster you go, the slower time passes. So if you were to go out at, say, 99% the speed of light for a while, turn around and come back, okay, you would be younger than the people that you would return to on Earth, because their time would have passed faster than your time. So time is, if you pardon the expression, relative.
Right.
Relativity, yes.
That's right. Well, let me ask you this, because I am familiar with that. I can picture like a YouTube video where there was a clock in space and a clock on Earth and sort of the asynchronicity of it.
Yep.
What about something that's maybe less studied, but I experience, which is, when I'm like stuck in a routine, it seems like time goes by quickly. Months pass. When I'm traveling, and sometimes my wife and I do this, we'll take 6 months and we'll move to a different place every month over that 6 month period. It seems like time is moving much more slowly. Do you think that we're actually slowing down time, or do you think that is more of like a memory and a consciousness sort of thing?
I take that to be entirely perceptual, which
Okay.
is to say that the time isn't changing rates. It's
Hmm.
the processing of time in your mind that is changing.
Okay. Interesting. Okay, so we can change the way that time feels with our minds, but you also believe that whether we're here or not, time exists and it is flowing.
Yes, correct. That's exactly my take.
Okay. Okay. Um, let's see. Do you think time travel is ever going to be something that we figure out?
If you're asking, will we be able to go back in time?
Hmm.
I would say the answer is no.
Okay.
I don't perceive, I don't know of any property of space that would allow that to happen, of space time, I should say.
Hmm.
Given Einstein's theory of general relativity, if it is correct and complete, or almost complete, then no, I don't think time travel going back is possible. Is time travel going forward possible? Definitely yes. Because as I just said, if you go out really fast and then come back really fast, your time will have passed very slowly, and the time on Earth will have passed faster. So you'll be arriving way in the future, depending on how long you've been traveling.
Hmm. Yeah. Do you think that, I mean, just the fact that you probably understand time, especially as it pertains to like physics, right? You understand it so well. Do you think that you perceive your world differently than I perceive my world because we think of time differently?
Because we think of that's an interesting question. I would say the short answer is no,
Hmm.
because just like you, I perceive time to pass differently under different situations too.
Hmm. Hmm.
So I think that's sort of built, hardwired into our brains,
Yeah.
is to have that occur, and therefore, you know, as a scientist, I may be more aware of it, but I go through it just like you do.
Yeah. Okay. Awesome. All right. Well, let's move to the next topic. I want to talk space exploration. And actually, before we get into like the actual exploration of space, space itself is something that I think you've studied pretty extensively, right? I mean, you have some books written, one of many books, many papers, all sorts of publications. One of them I was looking at is, I guess it's a series of books called like the What If series. One of
Yeah.
them is What If the Moon Didn't Exist? One of them is What If the Earth Had Two Moons? So, what are those books about? I mean, do you like think through like what if the moon didn't exist? What would happen?
Well, to answer that question briefly, let me talk about what has occurred to make the moon as it is.
Okay.
Okay. So when the Earth first formed, it was spinning much faster. The day, we don't know for sure, but it was somewhere between 8 and 10 hours long.
Okay.
And then an event occurred where we believe a Mars sized body struck the Earth and splashed a considerable amount of matter into orbit around the Earth. And at that point, the Earth had a ring. No moon yet. The Earth had a
Mm.
ring. And part of that impacting body then became part of the Earth. And the ring around the Earth coalesced to form the moon.
Hmm.
And that the moon, when it formed, was round numbers 10 times closer than it is today.
Okay.
And as a result, the tides, you should be sitting down for this, the tides were 1,000 times higher than they are now.
Like that one planet in Interstellar that they go to.
Yeah, right. And that because of those incredibly high tides and the rapid spin of the Earth, the friction between the water and the solid parts of the Earth because the Earth is spinning in one direction and the tides are going in the opposite direction,
Hmm.
the friction between them has been and continues to cause the Earth to slow its rotation.
Okay.
So the day went from 8 hours to 24 hours, and it's getting longer every second. Um, and as a result, that the moon is moving away from the Earth, and the reason it has to move away is the high tides from the Earth are pulling the moon. The high tide closer to the moon is pulling it forward, giving the moon energy, and that energy causing the moon to spiral away is causing the Earth's rotation to slow down.
Hmm.
So if the moon had never existed, the day would be in round numbers 8 hours long. The wind cycle, and we have enough of that now, would be profoundly different and probably much, much more active than it is today. And therefore, it would be harder to function in that world
Yeah.
for creatures like ourselves. And one other thing to think about is consider how much you have to do in 24 hours. Imagine if you had to get all of that done in 8 hours.
Yeah. We'd have to
So
go
those,
back to our time conversation and find a way
sure.
to like dilate it or something.
Yes, right, exactly. So those are some of the most important things related to what if the moon didn't exist.
That's fascinating. Do you know how, like you mentioned the day is getting longer and longer. Do you know like at what rate? Is it like every 10 years it's another second longer or something like that?
Right now, it's a thousandth of a second per century.
Oh wow. Okay, so very it's taken a long time by
Right,
our understanding and perception of time.
right, right on all counts.
Wow, that's crazy.
I'm saying that from memory, so you know.
Okay, gotcha. Okay, so let's go back to space travel now that we got a little bit of the craziness of the moon. Um, so there have been advancements in space travel. Obviously, we've got Elon Musk, we've got Blue Ocean or whatever the hell those other companies are. Um, what advancements in space travel and space exploration are like you most focused on? Like what are the coolest things that you've seen happening?
The coolest things about space travel, number one, is understanding how the human body would cope with lower gravity, or in the
Hmm.
case of the International Space Station, no gravity,
Hmm.
uh, over long periods of time. And one of the things that interests me, I don't know the answer, but I'm intrigued by it, is what if a child was conceived in space
Mm.
under zero gravity and was, let's say, born there? uh, that child's body, think of bone structure, would be
Yeah.
profoundly different than ours.
Hmm.
So, how would that child function? And could the child ever come to Earth? Which is, I mean, if I had to guess, I'd hazard a guess that the answer is probably no, unless there's an incredible amount of physical therapy before the child gets here. So that's one of the things that interests me is life in space, if you will.
Yeah.
Um, I'm also very interested to know whether or not there is life or was life on Mars.
Hmm.
It is likely that there is liquid underground oceans on Mars. And if that is the case, do they have life? And I think that, I mean, that's one of the things that they wanted to bring back some samples of
Hmm.
Mars, and such samples might have, the remnants of life to tell us that it's still there, perhaps, or was there.
Yeah.
So that's another thing I'm particularly interested in. Um,
On the Mars front, real quick, is that you mentioned kind of like the Earth and Moon formation and how that happened. Did Mars go through a similar thing? Are they behind? Are they ahead of us, or is it a completely different sort of evolution of that planet and its moons?
and its moons, the answer is completely different because the masses of those moons are so small compared to the mass of Mars.
Okay.
It's likely they were captured, not kicked off of it.
I see.
And
Okay.
so hopefully that answers your question.
It does. On the life in space, I want to go back to that one. So you mentioned the basically like muscular atrophy, or I guess never even forming in the first place, right? With the lack of gravity. What are some of the other just kind of like dangerous or things that would make it very difficult to live in space? I mean, I've heard a lot of like cosmic radiation. I've heard a lot
Yes.
about that. What should
Yeah,
we be worried about there?
that was actually my next topic.
Oh, okay.
Um, and there's cosmic radiation. There are particles in space that were created in other stellar systems that are flying towards us and smashing into the space station, for example. Um, and those particles are called cosmic rays. Cosmic rays are not rays; they're particles,
Hmm.
and they can be dangerous in large quantities because they can damage DNA and so on. And if again, the question of conceiving children in space under those radiation circumstances, on top of which the sun emits both high energy electromagnetic radiation, X rays, gamma rays, ultraviolet radiation, as well as particles.
Mm-hmm.
So the combination of those two things is has great potential for harming life in space. So we have to protect life out there. And the more we understand, the better, hopefully, we can make the protection than, for example, exists in the International Space Station today.
Yeah. I mean, it sounds really challenging to live in space. Like, is it? Do you think it's even going to happen?
Uh,
That's
yes, the short answer is yes.
okay.
Um, I did write a book on the subject, The Traveler's Guide to Space,
Hmm. Okay.
all about these kinds of things. So,
Okay. Got it. Let me ask you about. I'm probably going to pronounce this wrong. Alcubierre Drive. Do you know what that is?
no,
It
I don't.
basically. Okay, so I was doing some research. It's basically the idea of like bending space time in order to travel faster than light.
Oh, okay.
Is that possible? Do you think we'll ever have that? Because otherwise, we're not going to go much farther than Mars, right?
Well, we could go out to other places because remember, if the faster you travel, the slower time passes for you. So if
Mm-hmm.
you're traveling at 99% the speed of light,
Mm-hmm.
you can go much farther than if you were going at 1% the speed of light because you wouldn't age as quickly.
How would it be possible to go that fast, though? Is that possible?
Well, that would be engineering tech. That would be engineering technology. The
Mm-hmm.
idea of warping space, the amount of energy that would be required is far beyond anything that we could conceive of today.
Mm-hmm.
And whether or not it would have the effects that you outlined is open question.
Okay. Interesting. Huh. All right, let's go into the last topic I've got for you. So this is quantum physics, and I I don't think you are a quantum physicist, are
No,
you?
no,
Okay.
I'm not.
So but let's explore this a little bit because this is the area that is very interesting to me too, where you've got quantum physics, which does not follow the same laws as physics of larger bodies, which I guess is we just kind of call general relativity is how we circle that. Um, why is it so difficult to unify quantum physics with regular physics? Like, what's the problem there?
Well, I guess the short answer to that is that the behavior of particles on the quantum level, the behavior of radiation on the quantum level is so profoundly different than what we experience as ourselves, for
Mm-hmm.
example, uh, that when you then take those basic concepts, which I'll describe briefly in a second, and
Mm-hmm.
put them all together on the quantum level, things behave very differently than they do on the large scale, and that's why they're profoundly different. So, for example, one could talk about the particles of matter, protons, neutrons, and electrons, and things like that. And conceptually, if you would think, I just said particles of matter, right? You would think of them as like tiny billiard balls, maybe,
Mm-hmm.
and that's profoundly wrong. It turns out that all matter has properties that we are familiar with of particles, but also they have uh, properties of waves, like ocean waves.
Mm-hmm.
And it's a combination of the wave and particle properties that give every fundamental type of particle, the properties it has. They're all different. They behave differently. And when you dig deeper, those fundamental particles, protons, neutrons, for example, they are built of other particles, even smaller particles called quarks.
Mm-hmm.
And so the behavior of particles on that scale is so profoundly different. For example, if you take two billiard balls, and have one hit the other, you know that the other one's going to move off, and you can calculate what direction and what speed and so on. Can't do that with elementary particles. They don't behave in such a quote unquote predictable way, and
Yeah.
therefore, as fundamentally different things, their behavior is uh, totally non-intuitive. Number one, and totally different than what we see in everyday life. And even when you think of like light, think of light, right? You think of light, we're typically taught that light is waves. But different wavelengths have different properties. The shortest wavelengths are gamma rays, and then longer, and then visible, and then infrared, and so on and so forth. But the point is that all light is also are particles. So the light waves are particles of waves. So each particle, called a photon,
Mm-hmm.
is a bunch of waves together, and those particles, the photons, interact with each other in wave fashion as well as particle fashion.
Yeah.
So at the quantum level, things are just profoundly different than on our scale, and that is the short answer of why they're so different.
Yeah. Well, one of the crazy experiments, here's another YouTube video I've definitely watched multiple times, is the double slit experiment,
Sure.
where where I think I think it is with photons actually, that they're
It
shooting
is.
through these slits.
Yes.
And, when you mentioned how they exist as particles, but also as waves, the crazy thing about that experiment is when we are observing what is happening as we shoot them through those slits, they are always behaving as particles. And as soon as we don't observe it, they behave as waves. And then we can go back and look at the results of shooting them through the slit. And we see that they went through the slit as a wave would go through the slit. So,
That's right. Yeah.
so why does our consciousness, and maybe we don't have this answer yet, why does just like our consciousness and the idea of observing those photons change them between particles and waves?
Well, it doesn't. It is our perception that changes. In other
Okay.
words, the particles going through the two slits, they're doing it the same way for all the trillions and trillions of photons that do that. It's only a question of when we look at those particles at different places and different times that we see different properties. It's not that they are fundamentally changing as a result of our perception.
Mm-hmm. Okay. All right. Well, this is another weird piece similar to time, where it
Mhm.
seems like it changes based on how we perceive it. It's like our brain is somehow makes it seem like things are changing. It's very weird. Um, what about, let's talk about many worlds interpretation. So this is I guess if you want to maybe explain like quantum entanglement a little bit and superposition and that kind of thing.
Well, it's a question of particles interacting with each other in ways that are not, in any sense, obvious or intuitive,
Mm-hmm.
but they can essentially interact in such a way that they change each other. They
Yeah.
get tangled up. Is that what you're looking for?
Yeah. I guess there's some weird experiments where, going back to the idea of observing the
Mm.
particle or not, right? So I think the quantum experiment is like they have these entangled particles, and I think they actually like shot them with a laser into space to like a satellite, and then shot each of the two particles to different spots on Earth. One was like in China, one was in America or something. And basically you don't know which spin direction those particles have until you look at one of them. And
Mhm.
as soon as you look at it, its spin is determined. It's like,
Ah,
oh, this is spinning up. And then if you know that that one's spinning up, then you also know that the one way over in China, way across the world, which previously didn't have a spin, just because I looked at it here in America, it now has a spin in China, like as if it was able to communicate, hey, someone looked at me and I had to choose my spin. It's like as if it communicated that all the way across the earth to China faster than light, basically. Do you know that experiment?
conceptually, I do. I don't know that particular one, but
Hmm.
and it is true that when you do measure the properties of one particle, you cause the other particle to have the opposite spin in this case,
Okay,
uh,
yeah, yeah.
and and that's and that's okay because the particles exist not just as tiny billiard balls, but they have the wave properties, and those waves extend over a vast amount of space, so that they can communicate, if you will, with each other uh, over
Yeah.
large amounts of space, so that when we do measure one, the other one has to have the other properties. So, in other
Yeah.
words, when we measure one, we're essentially forcing the other to have the other properties. And they don't have to have that, even though they're far apart, until the measurements are made. And yes, it is true that they can be very far apart and still decay into the different particles at essentially the same time. And so that's one of the most intriguing properties of space time.
Yeah. Do you believe that there are multiple dimensions, multiple universes?
The short answer is no, I
Okay.
don't. And the
Damn.
reason I'm sorry, go ahead.
No, I was really hoping you would say yes to that because
I know you would, but I'm
I am
sorry.
I sort of believe in that, but if you would have said yes, I would have been like, okay, cool, I'm on the right track.
Well,
So what?
let
Why
me
not?
let me just flip it this way. As a scientist, if you can show me any evidence that that must be true, I am absolutely willing to change my mind.
Okay, got it. Um, okay, so no multiple realities, unfortunately. Do you believe that we'll be able to use that experiment that I just said with the particles and the spin and different
Right.
long distances? Do you think we'll be able to use that to send information faster than the speed of light? Because that happens instantaneously, right?
Well, that's an excellent question. It's something to be explored. It's
Yeah.
something to be explored. I don't think there's a definitive answer yet, and it will be intriguing to see what happens when they can, communicate over large distances by the, the spins of particles or other properties of particles. But so far, that hasn't happened.
Yeah. We've talked a lot about um, consciousness because it seems to kind of like impact a lot of these different topics. Do you have a take on like what consciousness is? Why we have it, how we got it? Does it exist after we die? I mean, how do you kind of think about consciousness?
Okay, good question. My take on consciousness is that it it exists because our brains are sufficiently complex. They can feed information in many directions at virtually the same time, and those interacting particles or waves uh, are providing information to different parts of the brain in such a way that the complexity becomes what we call, awareness, that the such as we have today. And follow up, from my point of view, it will be interesting to see if the computers that are used to make AI can become sufficiently complex, have sufficient feedback, have sufficient central regions of information, that they will someday become self-aware. So yeah. I'm not saying that that won't happen.
Yeah. Wow. Okay. Last question for you, and then I want to wrap things up because I want to. We're getting close to just past 30 minutes. So sometimes I wonder. We've got this history that we all know about, right? Written history. Basically, we make assumptions for like how long humans and civilization has been around. Based on what you know about planetary movements, the moon, asteroids, all that kind of stuff that can happen, do you think that like our current sort of like textbook understanding of history is probably correct? Or do you think humans probably lived long before that, and maybe it's sort of an iterative, civilizations pop up, some sort of crazy event occurs and it gets almost completely wiped out, and then it has to rebuild from scratch, and then it gets wiped out again, and then it's got to rebuild from scratch? And basically where we are today with our written history is just the latest rebuilding from scratch and getting us to where we are now. What are your thoughts on that?
My thought is that I don't think that we have cycled the way you've just described. Okay. I do think that we evolve, and that creates different forms of life, humans, if you will. Mm-hmm. And if as we go back in the past, keep in mind that the Earth has had a finite age, and it's only been able to sustain life for a finite amount of time. If we go back in the past, I believe that we will be able to get timelines for all the different kinds of life, Homo sapiens and the earlier ones. But I don't think that we are completely wiped out and start again, wiped out and start again. If that were to happen, in my opinion, when we got wiped out, the next iteration would probably not be the same as we are.
Got it. Okay, cool. Awesome. Neil, thank you very much. This was great. I've got a lot more to think about now. And I I appreciate you coming into the Lion's Den. Thank you very much.
My pleasure.